I'm just checking everything and then we will start. Okay. Okay. I think all is fine. Okay. Perfect. First of all, I welcome everyone to the Outcome School, and I'm super excited to see all of you joining this on particularly on Sunday morning. If you are joining from India, and if you are joining from US, Canada, it's late night for all of you. So great to see the effort that you are putting to learn few things in the AI. And I am really grateful to see that you all are joining this on Sunday. A few guidelines before we start the session. If you're using the web application, right, if you face any issue, just refresh the link, right, and then rejoin. And if you're using the white YouTube applications on the mobile app, so in that case you need to kill the application if you're on the iOS or Android, and then you reopen the application and then rejoin, right? So these are the guidelines if you face any issue, right? Now, because a lot of people are joining here, to control the spam, I have set up some guideline for that. Group chat is disabled to control the spam, right? And it will be overwhelming as well for all of you. So your single focus should be on the video, right? Whatever I am teaching, that should be your priority to learn, right? So from that only we will get all the information today. And as we are a very small team, I am the only one who is working on Sunday today. So let's appreciate the effort by liking this video now. Okay. So let's do that. Everyone, I'm seeing. Okay. And if you have any doubts, right? So I have added a link in the description that you can check. Ask your query, right? You can just put all your query there. And I can see I have added the AI agent for that. All the relevant query will come to me on the screen, and I'll read that and I'll answer that at the appropriate time. So let's start this. So all of you have joined means you want to do something in the AI. At least you want to understand what AI can do all of us for all of us. And from that perspective, I want all of you to be familiar with LLM, RAG, MCP, agent, fine tuning, and the quantization. So that is my promise to all of you that by the end of the session, you all will be familiar with all these topics for sure, right? So the only thing that you have to do is that you need to be in the session for the next 3 hours, and that I can guarantee that you will learn all the things effectively. By the end of the session you are going to be familiar with all these things. When people will talk here and there on the internet about all these topics, you will be already familiar with. It will not feel like alien to you. So that is my promise to all of you. Okay. So today whatever I am covering is 1% of the topic that I cover in my AIML program, right? So but these topics are very very important, as I mentioned in the post as well, that any developer working in tech domain, right, they should be familiar with all these topics to make yourself more productive, and you can think about more ideas whatever you project you are working on. So from that perspective, this is very very important whatever topics we are going to cover today, right? So the idea is simple, that you should be familiar with all these topics. It should not feel alien to all of you. Okay. So let's try to do that. Okay. So what I will do is that I will start the session now. It is already getting recorded anyway, right, on the YouTube. So let's begin. And I hope you all can see the uh, link in the description for asking your query, right? At the appropriate time, I will wait also that you all can put all your query, right? And then I can read from the screen and I can answer that as well. Okay. So let's begin. So, uh, so this session is all about the AI engineering overview. Right? But before that, I want all of you to understand the exact difference between the machine learning and the AI engineering. That is very important to understand first before jumping into the AI engineering. So machine learning means building the model, right? So there will be a developer, machine learning engineer. They will write some Python code. So for that, they will create the model. So writing the Python code, using some algorithm, doing some research work, and then feeding the data into that, right? So we'll train the model. So this model is like something like model.py. If it is written in the Python, it can be written in any language at all, right? So if it is written in Python, we'll call it as a model.py, and that is called creating the model. In that we will use some algorithm, mathematics, so on so, and we will have the model.py, and in that model.py we will feed the data. So we will train the model, right? And for all of these things we do the research work, algorithms, maths, and so on. So right. So they are called building the model like that, right? So machine learning engineers will go and build the model for the AI engineers, right? So so deep learning engineer, machine learning engineer, all those will come under this machine learning category. Now we have the AI engineering. That is something we will focus today for the next 3 hours. So AI engineering, right? As an Android developer, you can do the AI engineering. As a backend developer, you can do the AI engineering. As a DevOps, also you can do the AI engineering. So here we are going to use the model that is created by the machine learning engineers. So it is called using the model. AI engineering means using the model. So here what we do is that we make the model workable in the real product, right? So we are going to do something for that, so that we can actually serve the user using that model. So we will use some terms like fine tuning the model, quantizing the model, then we have the MCP, RAG, vector DB, so on. So and the for all of these things we do the system design as well. So effectively using the model is AI engineering, creating the model is machine learning. So that is something we need to be aware of. So this was about the ML and the AI engineering. Now, today our focus will be on the AI engineering. So we will try to cover all these topics that I have mentioned here: LLM, RAG, MCP, agent, fine tuning, and the quantization. So let's start. So to drive the discussion, what I will do is that I will take the example of AI tutor, and with this only we will understand all the topics, whatever I have mentioned terms, step by step. So everyone see this screen first. So by building the AI tutor, we are going to learn all those things. And here, when you open the Chat GPT, you see something similar to this. That hey Amit, ready to dive in? And here you can attach the PDF and you can ask something, right? And this interface, AI tutor, can be on the Android, iOS, or the web, right? So anywhere we can build this interface. So that is something we are going to take an example to understand all the terms that I have mentioned. So this is the AI tutor that we will build for the examples purpose. Okay. Now, in any application, what happens in a very simple way, right? You build some UI on the Android side or the iOS side or the web client side, right? You build that UI, and your UI communicate with the backend ultimately, right? So here we will have the server, so it will make the API call, and we will get some response, and that response we will render into some better UI format on the UI side, right? So that is something will happen every time, right? Now we will see the world without LLM. So this is the world which is without LLM, as you can see here, right? So before LLM era, right? If we talk about 2022 November, when LLM got released, that ChatGPT era came, right? So world without LLM is something like this. So you will have a UI there. You will search something like this: L1 and L2 loss function, for example, right? So you will get the blue links like this, right? So something like this you will get, and you will have the list of links. So for simplicity, I have shown you only one link here. Okay. So here what happens in that is that, so this is the UI, for example, this is a web UI, right? So web UI, we will make a call to backend. So if you have to build this, right, you will create the web AI, web UI, Android or the iOS like this, right? And then this client will make a call to backend, and then backend can use the API of the Google. So maybe Google already provides the API. You can just send the query, that user query is this: you give me list of all the items that I can show to the user. So Google will give you first item, second item, third item. So here I have shown the example of one item, right? So this is effectively the flow of any application that we can have: the web, the UI, the backend, and the Google, right? So the Google will give the response to the backend, and backend will simply send the response back to the UI client, and there we can show whatever the Google has given us, right? So this is the world without LLM, right? And now let's talk about the world where we have the LLM. So if you see the world with LLM, right now on the Chat GPT, so if you search something like this, L1 and L2 loss function, so you don't see any blue link or as blog link as such, right? We see something like this. So this is the kind of summarization. It will give you in a proper way. It will explain you everything, and that is something will be given to the users. So this is something we need to build for the AI tutor, and this has completely changed now, right? From link to we are getting the complete better explanation in the UI, right? So that is something has completely changed now. Now, so to build this, we need to understand the first term, which is LLM, large language model, right? So let's try to understand what exactly is large language model. So large language model, before understanding that, we need to understand exactly this part, language models, right? So this is more important, and then we can understand the why we call it as a large language model, right? So here is the language model. A model that understands means it can understand the English sentences, whatever the text that we have given. It can understand the grammar and everything, whatever is present in that. And then it can generate similar to that, right? So if it can understand the sentences, the words, the character, the letters, and it can generate or it can predict the text, right? Prediction means generating at all, right? So any model, right? If we can ask the model that this is my text, you need to understand this and summarize this. You need to understand this and you need to give me the next sentence or the next word that we can show to the users. So that will be called as a language model. So before LLM also we had the language models, right? But after the introduction of LLM, the large language model, two things changed there, right? So we started calling it as a large language model because of the two major factors. The first is large data set for the training. So we started training the language model with a large data set, means everything present on the internet. So we feeded all the data present on the internet into the language model, and because of that, there is something called parameters, weights that come out from the model when we train the model. So for now, that is only important to understand that there will be a model.py. We will feed the large data set for the training purpose, and that model.py will output some numbers, right? And that numbers will be huge in terms of magnitude, right? So large model size means large number of parameters will come out after the training process. So because of two reasons, we call the language model as a large language model, large data set on which it has been trained, and after the training process it is going to output you the large number of parameters, right? Those are numbers, 1 2 3, something like that, right? So just for now assume that they are numbers and they are stored in a file, right? Now, so something like this it will look like. So there will be a model.py. In that we can use some architecture like transformer architecture because they are famous right now, but that is not compulsory. Any architecture might come in the future as well, so we can do that as well, right? So for now just understand that we will have a model.py, and in that we will have 500 or 400 or 200 lines of code, right? And that code will be written by the machine learning engineers, right? Now in this model we are going to feed a large data set. We are going to feed a large data set, and somehow this model will output parameters.bin, a file, and in this file we will have a huge magnitude of numbers, right? So many numbers will be feeded in that, right? And because of that reason, m- maybe the file size will be 400 GB, right? So that can come out. So if you see that, right? So large data set and large number of parameters getting stored in a parameters.bin, right? So that is what we call it as a large language model, and this we call it as a foundation based model. So companies like OpenAI has release some of the open source model. So effectively they release two things. So if you see any model getting released on the internet as open source, right? So everyone talk about the weights, that weights are the gold, that is something we want, right? So if someone asks me today, you want data or you want parameters.bin, so I will say parameters.bin, simply because if I have the data and if I have this as well, right? So this is also something, most of the things are publicly available on the internet, model.py, right? So if I have this and if I have this, I will need $100 million to train because I need the GPU of that level, right? So I cannot invest that much amount in that, right? So if someone asks me that what do you want, right, so I will say just give me this and this, that's it. I will not want this and this because I will have to invest to create this. So these numbers are actually gold. So that is why if any company is open sourcing, for example Elon Musk Grok AI company, right, so they have released some Grok model which is open source. So effectively they have released two things, model.py and this parameters.bin. So in this the numbers are which are gold for all of us, right? So that is something they have released, and that we will call it as a foundation based model. So same thing, we will try to understand what exactly are stored in the that parameters.bin, right? So for that, let's try to understand this. So let's say we have the data set like this, as you can see on the screen. So these are the data sets for the real estate agent. So we'll try to understand this from the real estate agent, that what exactly is those parameters weights which are stored inside the parameters.bin, right? So that I will help you understand. So you can see this example that we have the number of bedrooms, square feet, balcony, and the price. So these are the previous deal some real estate agent has done, right? So this is the input and this is the output. If someone has bought this 2 bedroom, square feet, balcony one, so they have charged something like this, right? So from the previous deals, they know that something like this our data set look like, right? Now, what the real estate agent can do, they can create a model in which they can write price is equal to w1 into bedroom, so there will be a multiplier for the bedroom, right? Similarly there will be a multiplier for the square feet. Similarly there will be a multiplier for the balcony as well, right? So w1, w2, and the w3 are the multiplier and they are the weights actually. So what will happen here is that from the previous deal, somehow we will be able to infer that based on the experience, that for this data set we had these outputs. So these were the inputs and these were the output for those data set. So by seeing all this data, by doing some calculation, mathematical calculation, we can infer that w1 will come out something like this after the training process. So we will feed all this data into the model.py, which is here real estate agent model, right? So here we will feed all this data, w1, w2, w3 will come out from that after feeding all this data. So you can think of like that, from the experience, right, people will be able to infer what is the value of w1, w2, w3. So after some experience, after some training, we will come to know that the value of w1 is this, the value of w2 is this, and the value of w3 is this after some training process, right? So that is something is not important to understand as of now. Just understand that after some experience, after some training process, this model.py will output w1, w2, w3. Now if anyone asks the new output, right, so if someone gives you the new input, right, and they are asking for the new output, so they can give you something like this, right? So they can give you something like this. Now we need to predict the price. So what we will do is that we will take the model, and our model is this effectively, right? Now after the training process we have what, w1, w2, w3, and that can be retrieved again and again from the parameters.bin. We don't have to retrain again and again because we have first trained the model and saved all the parameters, all the weights inside the parameters.bin. So now we can read from here and load this equation, and simply we can feed number of bedrooms, square feet, and the balcony here, here, and here, right? And we will get the output like this. So weights are those numbers which we get after the training process. So similarly in the large language model, right, large language model, we get all those weights w1, w2, w3. So your model.py will look like something like this. So you will have the model.py, just the pseudocode I have written here to just help you understand what happens in this model.py. So you write some code like this. For example, you have only three weights, right? W1, W2, W3. So you initialize the weights with 0, 0, 0, something like that. And then you write some architecture, some code. Not important to understand what is written here. Just for understanding purpose, I have written that you understand that there will be a weights in the architecture model.py written. And then we will load the model and we will say, okay, let's initialize the weights with 0, 0, 0, and feed the data into the model somehow, right? And then the weights will come from the training process, some value of w1, some value of w2, and some value of w3. So like that we will get. So first we initialize with 0 0 0, and after that we get, after the training process, some real good optimized value of w1, w2, w3, right? And then we save to a file, parameters.bin. So those numbers are saved in the parameters.bin in this model that I have shown you. Now, when we have to predict, so simply we will load the file, and from there we will read the weights, and then we will ask the model, hey model, you take this weights and you also take the input that user has given, right? The number of bedroom, balcony, and the square feet. So those things we are going to feed into the model, and then we will get the output like this. So this is the output for that, right? So something like this model.py looks like for the large language model as well. So the major difference will be that instead of only two weights, three weights, right? Those weights will be in the magnitude of millions or the billions as well, right? So that is the major difference between what I have shown here and what would be present inside the large language model model.py, right? So here for the simplicity, I have shown only three weights, right? But in the large language model, you will have billions, millions in that magnitude, right? So now let's try to understand why I mentioned 400 GB, right? So that is called model size. So model size I mentioned 400 GB. So I'll help you understand this. So for example, we have 100 billion weights present in the parameters.bin. I'm not talking about W1, W2, W3. I'm talking about W1, W2, W3 to 100 billionth W, right? So that is the thing that happens in the large language model. It will be in 100 billion, 100 billion, 100 million, like that magnitude, right? So let's take the example of 100 billion. So in the 100 billions parameter, when you have 100 billions numbers stored in the parameters.bin, right, that file will become huge. And how do we calculate the model size? Like this. So we say that number of parameters, that is effectively here 100 billion, and we multiply with the bytes per parameter. So let's say we have the floating point 32 bit, right? So our one number will look something like this. And if you consider 16 bit, right, so here we have 32 bit and here we have the 16 bit. So based on the precision, if you see this, right, so if you consider 32 bit, this number has more precision than what you can see in the 16 bit. So if you want to decrease the model size, you will go with the lower precision. Obviously it will have the less accuracy, but let's try to understand with this example. So we will have 32 bit higher precision in this case. So each number will look like this. Each number will look like this. So if you have 32 bits, 32 bits means how many bytes? 4 bytes, right? 32 bits means 4 bytes. So one number that is present in the parameters.bin will take 4 bytes of memory. And when you have 100 billion, right? So like this we can calculate 100 billions with 32 bits, right? So 1 byte is equal to 8 bits. So 100 billion will come something like this. So you have 100 billion parameters, numbers stored, each one is 4 bytes. So if you calculate, ultimately you get 400 GB. So when someone says that I have a model of 100 billion parameter, 32 bit, you can simply say that that will take 400 GB on a machine when you are going to have that, right? So that is a 400 GB for this. Now, if you talk about this 16 bit, right? If you talk about this 16 bit, right? So that will be half of the 32 bit, because it will take only 2 bytes. And if it is taking only 2 bytes, that is going to take 200 GB. So we can decrease the model size, we can decrease the precision, we can decrease the accuracy to make it workable on a machine where we don't have the 400 GB of the capability, right? So like that we can decrease the model size. So like this it happens actually. So now when I say large language model, so you don't need the internet, you don't need anything as such. So just see this PPT. This is very important. We need to understand what I have mentioned here. Hmm. So this is something is important for us to understand. Running the model, and here in red letters I have written that it works completely offline without the internet. And this is something a magical thing we need to understand, right? And actually this is not a magic, right? So if you have your laptop, right? If you have your laptop, you can download the open source model, right, present on the internet, and you will effectively download two things, right? You will effectively download only two things. One is model.py, in which code will be written to load the parameters.bin and make the object of the model, and you can feed the data in input for the prediction, because they have already trained with the data. Now we don't need to feed the data, we need to feed the input for the prediction, right? So anything present on the internet as a open source large language model, you can simply download that, and you can keep those two files on your machine locally, right? So what will you do? So for example, you can download the model which is of 10 GB, 5 GB, 3 GB, 2 GB, 20 GB, like that, based on your machine capability, right? So for example, here we have the model.py and we have parameters.bin. So two files you will download, model.py and the parameters.bin, effectively, right? Now this is a directory on your laptop, this is a directory, and in that folder you will have model.py and the parameters.bin. That's it. And now you switch off your internet, right? No need of internet at all. Now if you say he is a good, right, so somehow the model has been trained on the large data set, so it has captured, learned so many information from the internet, so that it can give you this prediction. So it doesn't need any internet at all, right? That is very very important for all of us to understand, that large language model works completely offline, right? So there is no need for the language model, and in fact language model is like a kid, right? So you have taught them something, right, a kid, and now the kid is present in a closed room and there's no access to the internet, and that is something we have to think as an LLM, right? It means that the LLM cannot make a network call. So there is a common misconception on the internet I have seen. LLM makes the network call, right? That is a complete wrong statement, completely incorrect statement, right? LLM is simply what? Model.py and parameters.bin present in a directory. By having the Python, you can simply run Python space model.py and ask he is a good. It can give you is a good boy, right? Simply. So it can run completely offline. That is very very important for all of us to understand. And large language model only does what? It understand the language, it understand the sentences, and it can do something for you like summarize, predict. So like that it can do. No, it cannot make a network call for all of you. It cannot do any other things. It can only understand the language. Just like a kid, if you have taught English language to the kid will be able to interact with you in the English, right? Kid will not be able to use the mobile devices and go and do something on the internet, right? He or she can only communicate with you. He or she can simply mimic what you are saying. So those things completely LLM can do. So from now onwards, you all have to think that LLM is a directory. In that you have model.py and the parameters.bin. That's it. And it can completely work offline without the internet, right? So that is the capability of the LLM. So now some maths numbers, some magical things is done internally. So that I cover in the classes when I do for the outcome school. Now, effectively, what is happening here, right? So first you give what? He is a good, right? So internally it tokenizes. So you can just consider that a machine only understand the numbers. A machine cannot understand text format, right? It can understand only numbers. So you will have a mapper file. So for example, you have the mapping, hash map, table, dictionary, like that. In that you have stored 12 means he, 7 means is, 5 means a, and 42 means good, like that, right? And that is called tokenization in some way, right? So converting a text into the number, because the machine, the language model understand the numbers in a better way for the mathematical calculation, right? It has to perform some operation to give you the output, right? So plus and minus, it has to do the multiplication and so on, so some mathematical operation. So because of that, it has to be converted into the number format. So this is how we simply do this. We convert this into the number format, the tokenization process, right? Then there is something called embedding. So you can check on my YouTube channel what are embeddings. For now, that is not important. It is just that we convert this scalar number into some n dimensional array, right? So this is something three dimension it has, right? So again, into the numbers, and these numbers again represents what? This represent he, this represent is, and so on, so, and finally we feed these to the model. So these are effectively done in this directory only. I have just shown by expanding that so that you understand. Model understand numbers, model doesn't understand the text format. So we need to map the text into the number. And again, model will output what? Everyone say at your end. Model will output again, once again, the numbers, and that again in the vector format. And now what we will do, we will reverse of the embedding will be done. And again, we will have something like this. So now in the mapping file, we have written that, okay, 55 means boy, 42 means good, right? So we will reverse of the tokenization will be done, and then we will get is a good boy. And this is how the large language model works internally. So we feed the number, we get the number, and we remap using the mapping file that we have from number to text. And this is what everyone is doing internally: ChatGPT, Gemini, whatever the models we have on the internet. So now, as I emphasize on the fact that model works completely offline. So that is something you should always keep in your mind during the discussion, in interview, whenever you go, right? So if you're talking about LLM, that should stick in your mind that it works completely offline. So now see this. Suppose we train the model in the year 2020, right? So this is the example I am taking. So this statement is very, very, very important. All of you have to keep in your mind for this class. Suppose we trained the model in year 2020, right? And as we know, as you all know now, that model works completely offline without internet, right? So it means on your laptop you will have the directory. In that you will have model.py, 500 lines of Python code, and the parameters.bin maybe of 400 GB, right? Like that. So now if you ask the model that what is the current Bitcoin price, what it will give you? Think for a second. And we need to emphasize that the model was trained in 2020, right? It will give you a older price, or it can say, because see, if you train the kids, right, so kids can be sometimes smarter, right? So they can tell you that, okay, you are asking something which need to be gathered from the internet in real time. So model can say you two things, right? One, that model is not capable enough to understand that you are asking something should be taken from the real time data. So those dumb model will say you what? 50K, because it was trained on the 2020 data set, and it works completely offline. It cannot make a network call, right? But some good model can say you that, okay, I do not have the capability to make the network call, but one thing I understand that for this current Bitcoin price, so this is something which keeps changing in the real time. And for that matter, I cannot tell you, right? I'm sorry, I cannot tell you. Now, what you need to do, you need to go and use some tools. You need to make some other API call and do that for you, right? So I cannot do that. That is very important. LLM cannot make a network call, but LLM can tell you that, hey, I'm sorry, I do not know, right? So LLM is smart enough to do that, the current one, right? The older one might give you the 50K USD, right? So this is the issue, right? If you train the model in 2020 and it works completely offline, and if you ask the current Bitcoin price, it can give you the previous data. And right now, if you see, the 66K is the current USD price, right, for the Bitcoin. So it cannot give you the current one because it works completely offline, right? Now what we can do, right? So you might start thinking in the direction that we can retrain the model, right? But that is completely wrong answer. The reason is very simple. You can think of for a second, right? So, model, we cannot retrain the model because of the fact that again it will take $100 million, right? And it is GPU intensive task. So we cannot just keep on retraining the model in the real time. That is not feasible, possible at all, right? So we will not again retrain the model, because if you retrain now and then again if you ask the current Bitcoin price, again it can fail because the Bitcoin price changes in the real time. So two things: pricing and the timing issue as well, right? In the real time we cannot retrain the model completely, so we cannot have that approach. So instead of that, we will always have the model like that only, because that model understands the language, right? And that is more than enough for us to do extra thing, because that can act as a brain. So for that matter only, we will introduce a new term, and that is called RAG. So here is the second term that I'm going to introduce today is the RAG, right? So the problem was that model was trained in 2020, and you ask something of the real time. And if you ask something which is of real time, the model is not going to give you that, because it was trained in 2020. So for that matter only, we will introduce something called RAG. So let's try to understand RAG, right? LLM we have understood. Language model, large because of two reasons. It has been trained on the large data set, and it outputs the large number of parameters, and because of that we say large language model, because parameters.bin can be of 400, 200, 300 GB, right? So because of that we say large language model. Now the large language model was trained a while back. It cannot give you the real time information, so we will try to understand the RAG, right? So RAG means retrieval augmented generation, right? So here using an external source for the updated information, right? So we need to do something here so that we can get the updated information from the internet, right? So that is something we need to do. Somehow we need to incorporate that information, and we need to give that back to the users, right? So simply if you see, right, retrieval means fetching the relevant information from the external sources. Your external sources could be the document, a PDF, a database, or some web API, right? It could be anything. You can fetch the information from any place, right? Now augmented means adding those retrieve information to the model context. So now we will see why I am saying this in some time. So whatever information we have gathered from the external sources like database, API, document, PDF, so we will get the information from there, and we will feed those information into the LLM. Again I will say that LLM is very good at understanding the language and generating the grounded response for the user, which we can serve directly to the user, right? LLM is very good at understanding when we say something, and it can answer you in a very grounded way so that we can directly give the response back to the user, right? That's it. There is nothing more than that LLM can do. That is very, very important. Again, I am repeating that. Okay. Now, so this is something we will see in some time, that what I am saying here, we will retrieved information will be sent to the model, and we will see why. Now, generation means simple. As we know that LLM can generate a grounded response, the final answer, because the model has the previous knowledge that how I should write the answer for the user, how I should frame the sentence for the user, right? It has the language understanding, so it can do all of this for us. So we cannot simply say to the user 65K. Better to say what? The current Bitcoin price is 65K as per the real time data, right? So this is a better sentence framing for the users, right? So for those sentence framing, the grounded response, we need to take the help of the LLM, because LLM is very good at understanding, framing, generating the grounded response for the users, right? So that is what LLM is capable of. Now, here what we will do, so we will have the client, we will have the backend. So like this, our architecture will look like. We will have the client, we will have the backend, and then we will have the LLM. So this is something, just think that this is present on this machine or a different machine, doesn't matter, right? So that is the last thing that you should think about, right? Okay. So the backend is here, and here this is the LLM. So how this flow will work, like, you ask from the client, give me the current Bitcoin price, right? So on the backend, you will write some brain logic. Your backend is becoming a brain here, right? For now. So backend, on the backend, some smart developer has written, if and else, if user ask anything about the crypto price, I will go here. That brain logic you need to write on the backend side. Or in general, if user ask anything in general, for example, what is reflection, what is Kotlin, what is Android. So I can simply go here, ask the LLM, and LLM can give us what is Android, what is reflection, and so on. So, right, it can give you what is AI, what is transformer, right? All these things LLM can give us. So that if and else we need to write here. We need to write here that if we have that crypto Bitcoin pricing, and in that case we have to go here. Otherwise, we have to go directly here. So like this, we can simply write. So that is the flow that backend developer will have to write, and backend developer will try to make this backend as a brain, right? Ideally that should not be the brain, we will see later, but for now this is becoming a brain. So here so many if and else will come, and we will see how. So first, what will happen, ask what is the current Bitcoin price. Backend will decide, okay, I have to go here. So this crypto API will return 65k. That's it, 65k this crypto API will return. Now the 65k will come here, and now this backend will say to the LLM, hey LLM, user has asked that what is the current Bitcoin price, and I have received the response from the crypto API that the current Bitcoin price is 65k USD. Now you give me the grounded response that I can solve to the user, right? So LLM is very good at summarizing, creating a sentence, framing the sentences, right? So it will simply output the current price of the Bitcoin is 65k USD as per the real time data. So that sentence we will simply send back to the user. Obviously we can write some extra code here to frame the sentence as well, that is completely fine, but in future you will have a lot of use cases how to frame all those things. So for that matter only, we will do all these things via LLM, because LLM is very good at understanding and generating and framing the sentences. It understands the grammars in English language, because it is a language model. So for that matter, we will send the final for the final response. We'll ask the model LLM, hey, this is my input from the user, and this is what I have received from the crypto API. Now you tell me what I should serve to the user. So LLM will give you the grounded sentence that we can serve to the user. So this is how, and this is what we call it as a tools as well. So tools are used to interact with the world by executing the external functions, API code beyond their internal knowledge. So LLM was not capable enough to fetch the current Bitcoin price. So we use some tool. So here crypto API is a tool that backend has used. So backend will call the crypto API and it will send 65k. We will send to the LLM, and then finally LLM will give the grounded response to the client. So this is how the complete flow works, right? Now, so this is called RAG, means we first retrieve the information from the external API, and then we feed those retrieved information into the model context. So we are feeding whatever we are getting from here, we are feeding to the model. Okay, now you need to do what? This is the input from the user, and this is the output that I have received from the crypto API. Now you need to ground the response so that I can simply revert to the user, and that is what we are adding the retrieved information to the model context, right? So that we add to the model. Now model will simply produce a final answer by using both the model knowledge. Model knowledge is what? Model is good at grammar, understanding the language, right? And then the retrieved data that the model has, right? Which we have sent to the model in the context, right? So the model knowledge plus the retrieved data, combining both, it will generate a better response for the user. So this is how the complete flow works. Now, so that was about the RAG, retrieval generation. Now let's try to see the another use case. So what we have done till now, if you ask what is reflection, it can give you, right? But now if you ask the Bitcoin price also, it can give you, right? So those two capability we have in the model. You ask anything, plus if you ask the Bitcoin price, it can give you. But if you ask this specific query, see the query what is written on the screen. So explain reflection based on the top 5 blocks from the Google search result, right? So that is something we have written, right? How the backend will identify. Someone has asked that this is the crypto price. So I said, just for now, understand that a very smart backend developer is there. He or she has used the regex, and with that regex, he's able to infer that something like crypto someone has asked, right? So for now, just we have to understand like that. Obviously, for that we need to understand a lot about the regex and some maybe some smaller model or something like that, right? So for now, that is a black box. Okay, no need to understand for now. So anyway, we will remove that with the LLM. We will see how. So now this is the query. Explain reflection based on the top 5 blocks from the Google search result. So model will fail or pass. So if you ask this to the, because as of now the backend developer has only written what? If and else for the crypto. That's it. And we understand that here we will have to make a network call to the Google API just because of this. And we know that LLM cannot make a network call because it is present in a directory in a closed room, model.py and the model. That's it, the parameters.pin, right? So that is something is present like this. So it will have to make a network call. So this capability we have not built. So for this, what we will have to do, we will have to update our system, right? So again, we will ask the backend developer, hey backend developer, what you do? You add another if and else, right? Another if and else, that if user asks something to get from the top 5 blocks, you need to do some if and else extra for that. Again, some super brain we are doing at the backend thing. A great super backend developer has written that code. So one if and else for this, another if and else is for this, and we have the Google API, because this will fetch the data from the Google API. So again, if user asks this, if and else will say that okay, let's go to this service, fetch the data, and send all the data that we have. Send all the data that we have to the LLM, because LLM is good at what? Summarization, right? Because we will gather 5 HTML content or the text content from the top 5 blocks, right? We will have the blog content of 5 pages, right? Because we have the top 5 blocks. We'll fetch the data from there, and so we cannot simply dump those 5 blocks to the user, right? It will be very hard to understand because that user wants a summarization. And because of that matter, simply whatever we will retrieve from here on the backend, we will again send it to the LLM. And LLM is very, very, very smart at doing the summarization. So now LLM will do what? Simple, a directory is there, model.py and parameters.pin. So it will simply summarize and give you the response, something like this. Something like this, you will get the response. Something like this, right? Explain reflection and something you will get here, right? In the best summarized way that you can understand, right? Now, so here, if you see, a lot of things are getting added on the back end, right? Now, once again, if you change the query, right? If you change the query that now explain me reflection based on the top 5 videos from the YouTube search result. I do not want the answer from the top 5 blogs. Now I want the answer from the top 5 videos from the YouTube search result. Now, again, our system is going to fail. Again, our system is going to fail because LLM cannot make a network call. On the backend side, we do not have any if and else for this, right? So LM will say I cannot have the answer for this, right? Now, again, to incorporate what I am discussing right now, we will have to add one more if and else to call this API, call this service, right? So, like this, we will keep on adding so many if and else, so many logic on the backend side, and and if you closely observe here, UI will call the backend, and backend has to decide where I have to go first. Either I have to go to the crypto API, or I have to go here, or I have to go here, right? So we will keep on adding if and else check, and that will become a super brain on the backend side, and that is something we cannot do, right? A lot of things will be added on the backend side. We need to avoid that. We need to avoid that. So, but with this system, it is completely fine that we can get the response. We can get the response, but so many if and else we are adding here, right? So earlier, to have the real time data, I introduced a term called RAG, right? And now to solve this issue, that lot of if and else will be added on the backend side, and our backend is going to become the brain. Backend is going to become the brain. So I'm going to introduce a new term to solve all these issues, and you will see getting solved very easily, right? And what is that term? That is called MCP. The better solution will be MCP, the Model Context Protocol. So you might have used HTTP request, right? So whatever the HTTP is for the web, the same MCP is for the AI context. So we have to communicate from one machine to another machine. So we make a request via HTTP GET post request, so on and so, right? So that is a standard protocol to have the communication between any two machines. For example, your mobile can communicate with the server hosted in USA, right? So we need to have a communication medium, and that communication medium is HTTP for the web, right? Similarly, a system that I have built here need to communicate with the AI world, right? For example, AI world I am saying, right? So for those there is something called MCP. So what HTTP is for the web, MCP is for the AI context. So if you are in the AI world, rather than thinking about the HTTP, you should start thinking about the MCP. How I can use the MCP? So MCP is the open source standard for connecting AI applications to the external system. So now, if you have to fetch the crypto data, you will look for some MCP server already available on the internet. If you have to fetch the data from the YouTube search result, you will look for some MCP server already present on the internet. So you will not look for normal API. So you look for MCP, and how that is going to help us. That is very important to understand that. So for now, you might be thinking that I will call the HTTP. I can call the MCP in the similar way, and I can call the HTTP. Why not call the HTTP simply, right? So we need to convert our backend super brain to a dumb backend, right? So our brain should be LLM. Finally, the brain should be LLM. LLM should inform a lot about what user query is. We should not write if and else at the backend side. So for that matter only, this MCP is very important to understand. So converting, like migrating the brain logic from the backend to the LLM is done by using the MCP, and that we need to understand now. So how the MCP server looks like, right? So there will be a server someone has created. You can also create, right? So you can find some website, MCP server, something like that. You can check on the internet. mcp.so is some website where you can find a lot of MCP server. So someone can write a code, right, and name it as a fetch crypto price. So there is a MCP server, and the tool name is this. So in AI world, we call it as a tool, a function name, a tool name, something like this, and some code is written here. So this MCP server will simply make a API call to the crypto, right? So that is the job of the MCP server. So there will be a server. Uh, for that, we will call it as a MCP server, and it will expose a tool, right? And internally it does something. That is not something we should care about. Its responsibility is to give the crypto price. That's it. But it exposes the metadata. That is something super important for all of us to understand. So here is the metadata. Here is the metadata that you can see. So every MCP server has to expose a metadata. It can expose a list of tools, or it can expose simply a single tool. So here I am taking the example of single tool just for the simplicity, just for the understanding purpose, because we are doing it for the learning purpose today. Okay, first we need to accept the simpler thing, and then on the top of that we can keep on building, and we can build a large system as well, right? But for that, simplicity is very important for all of us to understand first, right? So this is the metadata that the model will expose, sorry, the MCP server will expose. So this is the metadata. So here we have the name, so it will say that this is the metadata. And with this metadata, as a human, we can read this metadata, and what information we will get. So we can see that, okay, the name of the tool is fetch crypto price. Name could be anything. Name cannot say everything about what it does, right? Because anyone can put ABC XYZ as a naming convention, right? Now description is something is super important. It is fetch the current price of the crypto. Fetch the current price of the crypto, right? And now this is also super important, the input schema. So it is saying that, uh, when you want to use me, when you want to use me, you need to call this, right? Because you already know that I does this. So the meaning of metadata is that my tool name is this. When you want to you call this tool, if you are able to infer, deduce the information that you have to get the current price of the cryptocurrency. Now when you call me, you give me this input. Symbol is equal to Bitcoin, right? BTC, something like that we can send, and that should be in the string format, right? So that is what this metadata is giving as an information. So this is the information that metadata is giving to us. So this MCP server will expose the metadata, and as a human we can read this and understand what this MCP server does. So we will make a request something like this: symbol is equal to BTC, Bitcoin, right? So it can give you something like this: price USD is equal to 100k USD, 65k USD, whatever is the current price, it can give you. So it is the MCP server creator responsibility to write the code here to fetch the data from some API of the crypto coin, right? So that is the responsibility of the backend developer who has created this MCP server, right? It is not our responsibility, right? So we can simply use this MCP server, and our responsibility is only what? Gather this information. That's it. And make the network call using this request and get the response and do something with that. So we'll understand how we can do. Similarly, similar to fetch crypto price, we can have another MCP server called fetch Google results with content. Fetch Google results with content, and again some server code will be there making the Google API call and so on. So, and finally we will have the name, description, this and this, right? So query and so on. So similarly we will have some request and some response from there. So this is how we can get the response. We are asking 5 content, right? So it will give you 5 content from 5 website, right? Similarly, we can have the MCP server for the YouTube as well. Someone has created the MCP server for the YouTube. So he or she can expose, this is the tool name. What it does, it is very important. Description is very important. We will see why. So this is very important. And then there is a input schema, query and the max result. So user query is what is reflection. I want max result 5. That type should be number, and something like this: reflection, max result 5. And MCP server can give you the response in an JSON format that this is the result for you, right? So this is the result from the 5 videos transcript from the YouTube, right? Like that you can simply get. So instead of writing all those logic at our end, we can go and use the MCP server, and we will see how we are trying to avoid the if and else, and that is what we are more interested in to understand how. But for now, again, once again, all these MCP server will expose you the metadata. That is super super important. Description is something really really important, right? Here as well, read the description, everyone. Read the description, right? Once again, read the description. Super super important. Now, how the flow will work, let's try to understand here. Now our system will look like this. We will delete all the if and else from the backend. We will delete all the if and else from the backend, right? As soon as, so once you see all, I'm having the water. Just try to see what is there on the screen. This is very interesting, how LLM is going to become the super brain here instead of backend becoming the super brain. And that is something we want to avoid, backend becoming the super brain. Hmm. So this is the backend. From here we have removed all the if and else check, right? Now what we will write on the backend is that fetch all the metadata to which we are connected. So we will write three URL here: MCP1 server, MCP2 server, and MCP3 server. And first, as soon as we are loading the backend for the first time, right, the backend is up, server has been started. Once you start the server, in the init block, you will write the code that we need to fetch all those metadata, those JSON that. And what is the most important there? The tool name and the description is a super important thing in those metadata, and the type and all those things are already there in input schema. Tool name and the description, three things are there. So you all think that once in your mind that how many metadata JSON object we will get. The obvious answer is three, right? Because in this we have one tool, in this we have one tool, and in this we have one tool, right? So three JSON object we will get: first, second, and third, right? So that is the recipe of the backend. So as soon as the backend server has been started, you will load all those metadata on this backend. So all those metadata is loaded. So now you have to think like that. My backend server has all the metadata, right? Those metadata you can store in a variable, in the dictionary, in a list, wherever you want to store that, you can simply store on the backend server. Now, if those metadata is present now what we will do, we will get the query from the user. If user has asked what, give me, explain me the reflection using the what, explain reflection using the top 5 videos from the YouTube search result. Definitely LLM cannot do this, right? Because LLM is something present in the closed room without internet, right? LLM only understand the language, grammar, it mimics, it predicts, it generates the text for you. That's it, nothing more than that. So this query, now here is the magical thing that LLM does for us to become the super brain in this complete system. LLM is going to become the super brain, and that is where MCP does the magical thing. And that is why we appreciate that because of MCP, LLM has become the super brain, and we will see how. So this query plus, when we feed something into the LLM, we feed some query input, right? So now our input will become bigger input. Our input will become bigger input. So this query plus, we will feed those three JSON object. So we will feed those three JSON object as well. So we are feeding the tools, and that is what I am calling it as a metadata, right? So we are feeding the metadata of all those tools. So now this query, so once user asks this, on the backend we already have the metadata. Our backend has only one responsibility now, that club both the thing, the query and the metadata that it has retrieved when the server was started, right? So this metadata and this, both the things clubbing together will be sent to the LLM, right? So like this it will happen. So everyone see this flow, very very important flow, very very important. So this complete data will be fed to the LLM now. Now, LLM is very, very, very good at understanding the language, right? So LLM will go and see, okay, the user has asked something I cannot answer because I cannot make a network call. But the system has given me some tools metadata. And because I am good at English, understanding the English, I can understand at least one thing, that which tool will be useful, because I can understand English, right? So because of that, LM will read this. Okay, so this is face current price of the crypto. It means that no, I cannot recommend this tool because this is something about the crypto. Because I understand the English, this is not something. So it will emphasize on what description. This is super super important, right? Now see how description is helping the LLM to become the super brain in our complete system, right? Super super important. Now LM will go and read the second tool. Okay, search Google and fetch content from the top result. Okay, this is also something not related to any video. Okay, so LM can understand that like a kid. Now LM will read this description. Okay, three metadata, first, second, past, because I cannot use that. Okay, so this is the tool which I can recommend to the backend system. So now LLM will simply output this. So when you feed this, LLM output will be this for the first time. See here how LLM is recommending us go and use the MCP server, because LLM can understand language, the sentences, the grammar, the sentence framing, right? That is why LLM is able to understand that, okay, this description is super super important for me. I can understand that this tool is something I can recommend the backend to use that particular tool. So that is how this output will come from the LLM. Now, on the backend side, we will write that looping, only looping thing we will have to write on the backend. So first query to the backend, this and this addition to the LLM. Now LLM can give you answer like this. Now backend will check whether this is a grounded response or this is a tool response. Super important thing to observe here. That we need to observe here. Backend will check the LLM has given the grounded answer which can be sent to the user directly, or LLM has recommended some tools to use. So this time LLM has recommended this tool to use, right? So now what we will do, we will simply use this tool and call the MCP server, because LLM has asked us. And one more thing, LLM understand English. So LLM has given you a particular query and the max result as well, right? So it has read, okay, 5. Okay, the number format it needs. So I will frame the max result is equal to 5 in number. Okay, I can send the query to this server, right? So LLM will tell you, okay, you take this tool, the name of the tool is this, and you need to pass this parameters to the tool, right? So everything LLM will tell you. LLM is doing everything for you now. So now this backend will make the call to MCP server with this query and with this max result. Now we will have the response. And again, can we send the response directly to user? Think about it. Or do we need to call the LLM? Obviously, for the grounded response, ultimately we again call the LLM. Now we will call the LLM. LLM will see, okay, now we already have the response. I just need to do what? Summarization, so that simply serve those responses into the user plate, right? So like that we can give back to the user. So looping code will be done on the backend to and fro. LLM is the brain here. It will recommend us what to do, and accordingly we are going to do, right? So like that. So let's try to understand the complete flow once again. So user query is this. Metadata has come from the users. Sorry, from the MCP server. So this user query. and all the metadata we will combine together. We'll combine together both the things, and then we will feed to the LLM. So this will feed to the LLM, and LLM will give us this. So from the LLM, we will get this response. So this is the response from the LLM, right? And we feed it this to the LLM. So in this, we have three metadata, three objects for three tools that we have, right? Now, what we will do, we will call the MCP server with this query. Query is equal to reflection and max result is equal to 5, because LLM recommended us to call this MCP server using this query and the max result. Arguments already generated by the LLM because it understands the grammar. Now, MCP server will give the response like this, right? Now, it is our responsibility to have the grounded response. So, again, we will say, okay, so this is the user query, this is the tool result, and these are all the metadata. So, LLM can ignore the metadata this time. Why? Because LLM knows that there is something in the tool results. LLM is capable of understanding those English sentences that we have framed here, right? So this can be written in very, very different ways. Let's not worry about that. So this is the user query. This is a tool result that has come from the MCP. And again, all the metadata we can send or we can ignore as well. It is our choice, right? Because in some complex cases, LLM can recommend you another tool call, right? So that can also happen. So for the complex case, we will have to write that looping code at our end. Now, LLM can give you the grounded response. So this is a complete grounded response that you can have, and that we can serve it to the user directly, right? So this is something can be served directly to the user. So this is how the complete flow will work. So everyone understood? So whatever query you have, you can share in the Google form that I have already shared in the link. It's present in the description. Any query that you have who have joined late, right, can put the query in the link that is present in the description of this YouTube video. Okay. Now if you ask, if explain reflection based on the YouTube results, right? So it can give you, because it knows that yes, I need to go to the MCP server, all these things I have to do, right? So like that. So we have built the MCP server here and connected that to the backend server, and backend server is making to and fro with the with the LLM and all those things, right? So that is what it is doing. Now we have the AI tutor once again, right? So here, if you see, right, we have another query. So one question is that our backend is capable of interacting with the MCP. So I thought MCP is only meant for the LLM. See, MCP server is helping us in doing what? In sending the metadata to the LLM, right? MCP server is exposing extra thing, and that is something normal HTTP server doesn't expose, right? So it is something like HTTP server itself, but on the top of that, we have added some extra guideline that it needs to expose this so that those metadata can be used by the LLM, and now LLM can respond you something like that, that you need to use this tool, right? So ultimately MCP call, because MCP call is what, a network call, and as I mentioned, what, LLM cannot make a network call, it can only understand the grammar English sentences, right? Because of that, it can recommend you to do that, right? Now this query can be served, but at the same time, if you see, now if you ask this, will it fail or pass? We are asking what, explain reflection using the PDF. Now this is going to fail once again, because we do not have built any capability for the physics or PDF, right? So right now we can ask what is reflection, it can give you. We can ask explain reflection YouTube blogs, it can give you. Explain reflection using the YouTube videos, it can give you. What is the current Bitcoin price, it can give you. What is MCP server, it can give you, right? If you ask what are transformer architecture in the LLM, it can give you. But if you ask something like that, you explain me this from the PDF, so it will not be able to help you with that, right? Because it doesn't have the access to PDF, and we do not have any handling at all at the PDF for the PDF at the backend end. So for that matter, what we can do, one idea is that we feed the whole content directly into the LLM. Whole PDF content directly into the LLM. We can feed, right? So what we can do, we can add. So this is the extra layer that I have added. Extra layer, right? So we can have the MCP server to fetch the PDF content. Something like that we can add, right? So just assume that we have another MCP server that gives you the whole text content present in the PDF, right? So now, when you ask the LLM, right? LLM will say that okay, uh, you need to go and fetch the PDF content from the MCP server, and then you give me the all the things, right? So you give me all the things now. So in that matter, we will go to the MCP server because LLM recommended that okay, this is a PDF. I cannot read this. To read the content from the PDF, you need to go to this MCP server. Okay, so now our backend will go to the MCP server and read the PDF from the PDF content, that PDF that we have, all the content we can read from there. And now let's say the PDF is of 100, 200, 300 pages. So we have to ask what is reflection from that particular PDF physics book. So reflection might be present in one chapter or maybe two chapter or maybe one paragraph or two paragraph are enough to explain the reflection from that PDF. So if you feed the whole PDF, right? So LLM has a limitation as well, a context window size, right? You cannot insert everything into the LLM as a data. So you need to think about the context size window as well, right? So this will keep on changing based on the how the research is being done in the LLM, right? So it started with like uh, 28K, 128K, right? So right now the state of the art is 1 million token in one go, right? We can feed 1 million token. So it will keep on evolving, right? So we don't have to remember that. Just for the reference, you just understand that the current state of the art of the model supports 1 million token in one go. So we can feed somewhere around 1 million words, you can say, for the simplicity. 1 million words we can feed into the LLM in one go. So, so anyway, but when you feed the data which is not relevant, so obviously we are feeding a lot of data into the LLM, the whole PDF of 100-page physics book, and there might be a case that only one or two paragraphs, so only some chunk of those PDF are important, not all. So because of that matter, if we feed everything to the LLM, your response will be slow, and there might be a issue of the context window size because your PDF might be of larger size than the context window size. So two issues can come definitely. The slow response, because LLM will respond slowly because it has to do operation on 100-page PDF content, and there might be a limitation of the context window size, right? So that is something is there here, right? So LLM here cannot get all those things. So someone is saying, can you show the live demo so that I cannot do in this class, so that I do in the classes that I teach at Outcome School, right? So you can join that uh, program to learn everything effectively, right? So this is the overview, as I promised. So only overview part will be given in this. Okay. So this is specifically planned for the overview 3-hour session. Okay. So the LLM, right? So here we cannot feed everything to the LLM because of two reasons: slow response and the context window size. And because of that, this is something which is not feasible to do, right? So we cannot go with this solution. So we need to do what? We need to convert the PDF into some chunks, So 100-page PDF can be converted to multiple chunks. For example, 200, 300, or 400 paragraphs. So for example, just understand this is 10 page. 10 page has been converted to 100 paragraphs or 100 chunks, right? So like that. And if we have the text content in the number format, if we have those things in the number format, so if we have those things in the number format, we can do some mathematics operation and we can find which chunks will be useful for getting the meaning of what is reflection, right? So we convert all those paragraphs using some embeddings model, right? So that is not something to be discussed. That will give some numbers like this. This is important to understand, that that will give some numbers. So every chunk will give some numbers, and every chunk will have some text, right? All the paragraphs it converted into 100 paragraphs. So every chunks will have some embedding, some numbers. Now there is something called vector db. We are going to store all the chunks into the vector db, and vector db is optimized for the lookup, for the lookup. So all the paragraphs, all the chunks in the number format plus associated text has been stored in the vector db. Now what we can do, user has asked this, what is reflection? So query is reflection. Again we can use the embedding model, and that will give us this number. And now we will say to the vector db, hey vector db, you give me all the chunks which you find relevant for this reflection query, right? So it will go and calculate the distance. So this, so if you see, right, here this 2 and 3 are close. Observe here, right? So this number is very close to second chunk and the third chunk, as you can see here, right? This is very far away from that, this is very far away from that. So you can ask the vector db that you give me the chunks which are relevant for me close to what I have asked, right? And that is something vector db is optimized for the lookup, right? Now the vector db can simply give you two chunks. Now we will change the system, right? Whatever we have built, we will change the system. So we will build the MCP server. In that we will write ingest and the query PDF, right? We will write some code here. So effectively we are going to write some logic there on the MCP server, or we can use MCP server which are already available, right? So in that case, the name of the tool will be something like this. Doesn't matter. What is important is the description. So we will write ingest a PDF. Internally it will convert the PDF into the chunks, convert into the what, the numbers, the vectors, and then it will store. And then we can query that I want what is reflection. So it will give you not 100 chunks, it will give you only two chunks. So now instead of feeding 100 chunks to the LLM, we are going to feed only two chunks, because those we have gathered by using the vector db, right? Vector db is optimized for lookup for the relevant chunk, and that is how vector db is going to help us. So now you simply ask this is a PDF file, this is the location of that PDF path, PDF that we have, and this is a query. So this is the example request, and this is the example response from that. So you will have the chunks, reflection, something like this it will come. So if you ask 2, it will give you 2. If you ask 5, it will give you 5, right? So top 5, top 3, top 1, you can simply ask to the MCP server. You can add that as well here, top 2, top 3, but here I have kept top 2. So this is something you can get from the MCP server. So your MCP server will only give you the relevant chunk that should be sent to the LLM. That's it, right? So now our system will become something like this. Same thing, but we have updated the MCP server. Instead of asking for the whole content, we are actually using vector db internally, and that is giving us a relevant chunks that is important for that reflection. So same thing, just update the MCP server will help you making the system optimized, because on the MCP server we are using vector db instead of sending all the content to the LLM. Now, so this flow, how this will work, let's try to understand. So this is the query, physics.pdf, explain reflection using the PDF. All the metadata will be gathered. Now, how many metadata we will have? Everyone think and tell me. We will have, think once, right? We will have 4 metadata. So we will have the 4 metadata. 1, 2, 3, and 4, right? Now if you ask the LLM that this is my query, PDF path, this is the query, and these are the all the metadata. Now LLM understand that, okay, I need to do something with the PDF. So LLM will suggest you this tool, right? And it will give you the path and the query that you have to ask. So now you can simply ask this to the MCP server. MCP server will give you this. MCP server will give you this. And if the MCP server is giving you this, right, then physics.pdf, this is the query, and this is the tools and tool results, right? So this is a tool result, and then we have all the metadata that we have, right? So we will feed these to the LLM. Now LLM understand that I should not recommend the MCP server because there is a tool result which is relevant for sending this response to the user, right? So simply the LLM will give you the grounded response, and this is something we can send to the LLM. So this is how you can simply give the response to the LLM. So this is uh, something we can give to the user. So LLM will give you the final grounded answer that should be served to the user. So looping code we will do on the backend side. Just keep on adding the MCP server, updating the metadata. LLM will keep on recommending do this MCP call, do that MCP call. You have to do that, and again get the response. Add the response in the tool result. Send to the LLM. Get the grounded response, and that is how this complete loop works. Again, LLM will never make the network call. Instead, the LLM will just recommend you to go use this tool. Go do that. So like that it can do. So that is what LLM is trained for understanding the sentences, the grammar as a language, right? Now, now if you ask this, now if you ask this, your LLM will be able to give you the grounded response from the PDF. So if you read this, right, if you do this actual, that you can simply get that. Okay, so there is a reference in the PDF. I can tell you that reflection means this and that. So LLM can give you the response like that, right? So now this input from the user is something will be served to the user as an output response, and this system we have built by using the extra MCP server. And in that MCP server we had to use a vector DB to optimize the response time, to cater the window size limitation as well, so that we feed only the relevant data into the LLM, right? So that for that we use a vector DB. Now from the same perspective, right, now if you see, ask something like this. So if you ask the LLM, explain epoch in machine learning, right? So it is not going to use any MCP server because it is not related to crypto, it is not related to YouTube videos, it is not related to top 5 blogs, and it is not related to PDF at all, right? So it is not going to do anything with the MCP server. It will just serve you the response, right? But the thing is that we can observe that response could have been better, explanation could have been better, as you read my blogs on the outcome school, right? The simplicity that we teach. So that is something we do the very best on this planet earth, right? So explain epoch in machine learning, if you ask, right, the explanation can be good, but it can be made best, right? So for that matter, we can think of doing something for that, right? So because the LLM is trained on the whole internet, so it generalizes everything. It generalizes everything. So it reads the outcome school blog as well, it reads other companies blogs as well. So it doesn't focus on one block, it reads everything on the internet. So it has the general information, it has the general way to give you the response. So it cannot give you very specific to outcome school how we explain the any topics, right? So for that matter, I am going to introduce a new term, and that is called fine tuning the LLM, right? So now let's try to understand the another term. So we discussed LLM, we discussed RAG, we discussed the MCP, right? So the next term is fine tuning. So fine tuning is the process of further training a foundation model. If you remember, I mentioned when we first trained the model LLM 400 GB, there I have highlighted that this is a foundation based model, right? So on that there is an investment of $100 million. So maybe in the range of 910 crore in INR, if you talk about, right? So the fine tuning is a process of further training a foundation model. We will take the foundation model which has been already trained on the general data set present on the internet. And now we will do the further training on that for a specific data, right? So for example, here we will take the outcome school blocks. So if we have 200 blocks, we will read all the content from the outcome school block, and we will further train that to make it perform better for a particular use case. If we have to improve the explanation, we will just take again the information from the internet in the way that we want, right? So we can gather some of the blocks, and now we can feed those data again for the further training of the foundation model. So we are going to further train the model. But the good thing is what? Model already understands the language pattern, the grammar, the sentence framing, all those things the model has learned in general from the internet. And that we cannot do because of the investment. But now we can obviously fine tune the model, and that will be a cheaper option. That will be a cheaper option, and we will see, right? Why I am saying that in some time. So we fine tune or customizes the foundation model for a specific task or the domain. So for example, a model that is general model, right? The foundation model is trained over the internet, all the data, but we want something for the coding specific. So we can go and fine tune that model specific on the code present on the GitHub, right? If you have that option to do so, specific to the coding thing. Now in the coding also, you can go very specific that I want to fine tune the model for Python language, for the Android developer, for the Kotlin or the Java, like that, right? It will become better at those things. But for all those things, obviously we need the general intelligence as well. So for the general intelligence, already someone invested that amount of money to train the foundational model, right? So now training the scratch requires a huge data. So that is why we cannot train from the scratch, right? Already has the general intelligence capability, right? Now a foundation model already knows the general language pattern. So that is very good for us, that it already knows how to read the sentences and so on. So fine tuning is faster, cheaper, and more practical. Now, how we will do? With some line of code update. We will update some code in this. Few lines, 5 to 10 lines. That's it. Nothing more than that. So that we are going to update there. And when we update this, we will feed the data that we have in the outcome school. So all the outcome school data will be feeded to this. All the outcome school content data will be feeded to this. And now it will output, because it already had what? Numbers which was retrieved from the first foundation model, right? So these numbers are already gold. It has the general capability to understand the language, right? The English sentences. So this model will first load the previous parameters.bin, previous weights that we have. It will load all the numbers in the memory. Now, based on the outcome school content, we will feed everything to this, right, into the model. And now this model will be further trained, fine tuned to update those numbers here and there. So it will not update much, but some changes will be there in the number to finally explain the topics in the outcome school way, that how we explain, right? So this parameters.bin we can rename and call it as a updated parameters.bin. So this is a fine-tuned model in which same number of parameters are there, but they are updated here and there, right? So maybe some number will be 12.0, that might become 13.25, something like that, right? So those mathematical numbers will change here and there, but finally our output will be 100 billion parameters only. Number of parameters will be same, but those will be updated based on what new content we have feeded, right? So that is called fine tuning. So now we will use this model, this obviously the same model.py with some updated code, right? And then we have something like this. Someone has asked that explain agent. I will explain the agent in some time, already in the topic. Okay, so let's not worry about that. So that is next thing. So here we have the model.py, the fine-tuned model, and then we have updated parameters.bin, right? So now we are going to use what? Instead of instead of instead of using the parameters.bin, we are going to use this particular updated parameters.bin, that is retrained, further trained on the outcome school content. So we will use this now. So let's try to see this. So now, same MCP server, same backend, same client, same MCP server, same MCP server, same MCP server. What is changed here? Instead of parameters.bin, we have updated parameters.bin. That's it. Otherwise, everything is same. So now if you ask the explain epoch in machine learning, you will have the great explanation like outcome school, right? So now you can see. So like this, you will get the explanation. So this is how fine tuning can help you for doing the particular specific task, right? So that is something we can do. Now let's talk about the agent, right? So agent, langchain, there are so many terms, right? So we'll focus on the agent. So if you see, our system is this. Whatever we have built today for the AI tutor, this is the system. Now here if you see that in the AI world, we do not say agent. Always we say AI agent, right? So we will say AI agent. Okay? Now on this backend, there will be a 20, 30, 40 lines of code, right? There will be 20, 30 lines of code. What it is doing, that let's try to understand. So if you closely observe, agent is a system, AI agent, obviously it uses the tools. So it is using the tools, right? MCP server it is using, and this backend, the whole system that we have built is able to make the decision as well. And who is helping in making the decision? This LLM, right? Okay, go to that MCP server, go to that MCP server, and it can take multiple actions to complete a complex task. So task that we given that explain me the reflection using the YouTube video, right? So it can use a tool for that. This tool it can use. It can make decision which tool to use because LLM is helping us to do that, and it is taking the multiple actions. First, it is sending the query to the LLM, then making the MCP server call, and then again for the grounded response, it is sending to the LLM. Right, a lot of things it is doing. Right, so there are many things that it is doing. It means it is taking a multiple action to complete a complex task. So the piece of code that we have written here, that we have written here, right? To do all these things, interact with the LLM, do that, do this, right? So basically, any piece of code that uses tools, make decision by using some brain, take multiple action to complete a complex task will be called as AI agent. So if you just right now, if you write the code of 10 lines, agent.cpp, agent.java, agent.py, agent.kt, Kotlin, right? Or something like that if you write. And if you have written something like that in that, okay, uh, daily morning, what you do, you first go on the internet, search all the jobs available in my current domain, maybe as a backend developer or as an AI engineer, and read all the description, job description of those job posts, modify my resume, and then do what? Then update my resume based on those job description and upload the resume and apply to those websites, right? So you will write what? 10, 20, 30, 100 lines of code. So if you see here, it is doing something on the behalf of you. It is doing something on the behalf of you. So that is called agent. So if you talk about the flight ticket booking, right? So what do you do? So if you have to book the flight ticket, so you can open make my trip or you can call your agent. So you will call to someone and say that okay, I want from Delhi to Singapore, so you can book the flight for me. So that is a person who is doing the task on the behalf of you, and that is why we call it as a travel agent, something like that, right? So if someone is doing something on the behalf of you, that is an agent. And in the AI world, we call it as an AI agent because it can take multiple decisions, it can take multiple steps, and it can complete the complex task on the behalf of you. So you write any piece of code that does this, doesn't matter what language, doesn't matter what library you are using, but if your code is doing that, all these things, you can simply call it as an AI agent. So right now if you see on the internet, if you read AI agent, nobody's going to explain like this, right? So we need to understand from that perspective. Basic is very, very important for all of us to understand in this way, right? So that we can effectively communicate to the others, we can effectively explain this thing to the others, right? So anything that is doing the task on the behalf of you is the agent, and if you are doing it smartly by using LLM and so on, so any piece of code that you have written is called AI agent. So everyone, if you understood what is agent, give me a like on the video. Okay, right now. Good. So one of the library that we use for the this building the agent. So if you don't use the library, you are going to write 100 200 lines of code, and if you use the library, definitely the boilerplate code will be reduced. You are going to do the same thing in maybe, for example, 10 20 lines of code, right? So that can be done. So that is what I said. A LangChain is the library, a framework for building the LLM powered application. So this is how it can be simply done. So any piece of code that you have written will be considered as the AI agent if it does all these things. So that is what the AI agent we call it. Now, so that was all about the AI agent. So we discussed LLM, then we discussed this RAG, then we discussed the MCP, then we discussed the agent as well, AI agent. Now, and then we discussed the fine tuning as well, right? Now let's discuss about the quantization, which is the last topic. A lot of things to be discussed here as well. So quantization means reducing the model size to make it work on the smaller machine, right? So for example, this is the parameters.bin. So in this, as you all know from this class, that in this what is stored, all the numbers are stored in this, all the numbers are stored in this parameters.bin, right? So 400 GB, all those numbers are stored in this 400 GB, right? 100 billion parameters, as we have seen this calculation earlier, right? How we can calculate the model size. So 400 GB. Now each number, because it has 100 billions parameters, so each number represents a 32-bit floating point FP32. So your each number will look something like this, right? And now if you just load all these numbers and decrease the precision from 32-bit to 16-bit floating point, so your number instead of this will look something like this, it will look. So if it is looking like this, right, we can say with the confidence that this has a higher precision and this has the lower precision, and higher precision, lower precision. Memory, obviously it will take more because it has the precision more than the 16-bit, double the memory, right? And if it is taking more memory, for the obvious reason it will be slower, right? On the machine it has to do a lot of operations, so it will be slower. So precision will be low. We can experiment what precision we want, what machine we have. So these are experiments, right? We can experiment with all those floating point 16, 32, 8-bit, so on, so, and we can see what we can serve to the user, what is good for our company based on the expenses that we can have, right? So the precision, the memory will be less here, and speed will be faster because it has the 16-bit, because it will take less memory. So effectively what we do is that we load all these parameters in the memory. We can load in chunks as well, and then we just write 2 3 lines of code. That's it. Read the number, write the number, read the number, convert to 16-bit, write the number, again read the next number, convert to 16-bit, write the number. So all the numbers present like this in the same file, or you can create a new file, quantized parameters.bin, and you can write the number one by one like this. So that will be called as quantized model, right? And because of that, 32-bit takes 400, 16-bit can take 200 GB, 8-bit can take 100 GB, and so on. So based on your machine capability, you can obviously go for all this quantization. So if you see on the internet, right, you see something like this. So this is one of the latest model that Llama 2 has. Llama 3 is also there. Just the screenshot I have taken. And now if you see, right, so this model, and if you see this model, so now you can deduce that this model and this model, the only difference is what? This is fine tuned for the chat conversation. So this is a general model. It can do anything, whatever you ask. It can chat as well, but not in a better way. But this is a chat model, so you can chat in a better way. So it will feel like a natural conversation, right? So this is a model which is fine tuned. So this model and this model, if you see the size are same, right? 3.8 GB, 3.8 GB. So it means that simply that we can simply fine tune the model for a specific use cases. So now if you read on the internet, right? So this is Llama 2 7 billion parameter. Llama 2 7 billion parameter fine tuned for the chat, right? And now if you see this versus this, you can simply see the difference that there is a q word used here. So it is quantized. It is quantized. So it means both are chat model, but it is quantized and made smaller with lower precision, made faster for the different types of machines, right? So now if you read anywhere like this, you can read. So this is how you can read. So you can explore the website called Olama, right? Olama is the website, OLLAMA. So from that website only I have taken this screenshot. So now let's talk about the memory requirements, right? How much memory is needed? Someone has asked that how we can read all those things. So already I have in this class. Okay, the memory requirements. So training a model generally require 4 to 6x more memory than running it for the inference. Just a second. Hmm. Training a model generally requires 4 to 6x more memory than running it for the inference. Training a model. So inference means observe everyone. This might be confusing, right? Because sometimes we do not understand the meaning of inference. And I have specifically written inference so that I must communicate this. Okay. So inference means prediction. During the prediction time, we load the model in model.py in two mode. We can load in the training mode and we can load in the prediction mode as well, which is called inference. So during the training, a lot of things will happen because it has to optimize those weights. It has to learn those from the experiences from the previous deals, previous data. A lot of things it has to do. So because of that, internally we will have a lot of things like gradient, optimizer state, etc. So many things will be there, right? So these are something which happens inside the large language model architecture. So in my actual classes where I teach AI in machine learning at Outcome School, we code the LLM from the scratch, right? So we are going to build the LLM from the scratch and understand everything. What exactly is this gradient, optimizer states, whatever is there, right? So building the LLM from the scratch will give you more confidence to use the LLM, to fine tune the LLM, to quantize the LLM, right? So that is something we must do, right? So training a model require 4x, 6x more memory than the inference time. So when the model we are training, let's talk about this example. Llama 2, 7 billion parameter, and here we have the 32 bit. So as per the calculation, right? So we understand that when we load this model, when we load this model into the memory, 7 billion into 4, because 32 bits mean 4 bytes. 7 billion parameters, one is 4 byte. 7 into 4, 28. So inference means prediction. So when we are going to use the model for the prediction on your machine, so if you download this model, you need 28 GB of the RAM at least. So if you have 32 GB RAM, maybe this can load if you have 28 GB extra left for that, right? If you have that. If you have 64 GB RAM, now you understand that with the 64 GB RAM, you can use the model for the prediction. But definitely you cannot train the model, but because it will require 112 GB because we have taken 4x. So this 4x is extra because of this gradient, optimizer states, and so on. So right now, if you download the model with 8 bit, for example, right, 7 billion parameter 8 bit, that is quantized model, right? Quantized model. So 8 bit model quantized will take 1 byte for one parameter, and we have 7 billion parameter. 7 into 1 simply 7 into 1 will give you 7 GB. Now even though if you have 16 GB laptop, definitely you will have 8 to 10 GB left in the RAM, right? So you can actually use this model for the inference on a 16 GB laptop as well, right? 7 GB it will take for the prediction phase. But again, if you are going to train that, it is going to take, here I have taken the example of 6x just for the explanation, 4 to 6x. So that is how this 4x to 6x will be converted, right? So prediction will take this much memory. If this is the model, training will take this much memory, somewhere around, right? Inference for this model 8-bit will take this much, and training will take this much. So this is how you can infer by seeing the model that whether I can run this model on my machine or not, right? So now you all should be able to deduce this information just by seeing this line, right? So all the model you can see here and infer all those information, right? And in detail also you can go Olama website. Now, if we have to fine tune, so what we discussed now, we discussed that if we have to load the model for the prediction versus the training, prediction will take X amount of memory, the training will take 4 to 6x of that memory, right? So that is something we have learned. So now let's say we have to fine tune the model. So here I have written that same memory as training, because in the fine tuning as well, it is going to load everything. Means the all the weights, all the parameters plus the gradient, the optimizer states, and etc. Everything it is going to load into the memory. So full fine tuning will always take same memory as the training memory. Same memory as the training memory. So what you can do is that if you have this model, if you have this model, inference will take 28 GB, as we know, 7 into 4. And then the training, as we know, the 4x it will take. So as I mentioned, the fine tuning, which is the full fine tuning, will take same memory as the training. So if you have a laptop of 16 GB, so you cannot do the inference, you cannot do the training, you cannot do the fine tuning at all. You cannot do, definitely, right? Now, a quantized model as well, you can use it for the inference. You cannot train if you have the 16 GB memory. You cannot train and you cannot fine tune, right? Definitely you cannot do that, right? So there are better way to do that. There are different approaches for doing this fine tuning and the quantization. So let's try to understand that. Now we will take the example of 64 GB RAM. So if you have the 64 GB RAM, definitely we cannot train this model. Definitely we cannot do the full fine tuning for that, right? So this is doable, this is doable, something, right? So but let's say we have to do for this, so we cannot do that, right? So for that there is something called PEFT. Parameter efficient fine tuning. So low rank adaptation, we have two techniques here, low rank adaptation and the quantized low rank adaptation. Two techniques we have that we do. So let's try to understand the low rank adaptation. Everyone focus on this PEFT, parameter efficient fine tuning. So if you see here, here I have not mentioned full fine tuning. It means we are not going to do the full fine tuning. We will do some part for the fine tuning, not the full fine tuning, and that is what we are calling it as a parameter efficient fine tuning. So low rank adaptation, which is the first technique. So in this, what we do is that we first freeze the model, the base model, the foundation model that we have. We freeze the base model, 400 GB file that we have, we will freeze those model. We will not update those numbers. So it means we don't have to load those into the memory, right? So like that, something like that you can assume for now. So we will not do any changes in that. Instead of that, we add some extra numbers, add some extra number in that. Few lines of code changes we will do in the model.py to add these extra number, right? That is what we will do. So what it does is that now we are not going to do the full fine tuning, we are going to do the fine tuning in some part of the model, and that too by adding the extra memory, extra numbers, extra weights. That is something we will add so that our model will become capable of doing some specific task, right? So extra weights we will add. So that is what I have written. So this was the model, right? So if you see this 7 billion parameter, 32 bit, 4 bytes each, is going to take 28 GB, 7 into 4, for what? For the prediction. And for the full fine tuning, as we know, it takes the same memory as of full training. training and full fine tuning will take the same amount of memory. So 4x to 6x. So if we have the laptop of 64 GB RAM, we can do the prediction, but we cannot do the full fine tuning. But we can do the low rank adaptation fine tuning, means parameter efficient fine tuning can be done. And this only takes 1.1x of the memory because of this addition. That's it. So same model, inference will take 28 GB, but if you do the parameter efficient low rank adaptation technique, fine tuning, 1.1x of the inference it will take. So now if you have the 64 GB RAM, right, you can actually do the low rank adaptation fine tuning, and we can definitely do this, right? So this is something can be done on your 64 GB RAM. Similarly, if you take this example, right, so 7 GB was the inference, 7 GB into 1.1x will take for the fine tuning. So only around 8 GB. But for the full fine tuning, it is going to take 42 GB, right? So that is not something we can do on, for example, we take the example of 16 GB RAM. So this is something we can do on the 16 GB RAM. This is something we can do on the 32 GB RAM or 64 GB RAM. Definitely we can do, right? But this was not possible. So this is how we can decide which fine tuning is good for based on the machine that I have, right? So now the last thing that we have the Q low rank adaptation, the quantization low rank adaptation. So now let's take the example of 16 GB RAM. So if we have the 16 GB RAM, right? So this model, right? So this model in inference it will take 28 GB, right? 28 GB. And if you say, right? So if you do the low rank adaptation fine tuning, this model will take 28 GB, and for the fine tuning parameter efficient low rank adaptation technique will take 31 GB. And now we are having the constraint that we have only 16 GB RAM. So one additional step that we'll perform that we have learned today is quantization. So the name is quantized low rank adaptation. So first we will quantize and then we will apply the same technique. So let's see how we will do, right? So 28 GB inference, 31 GB for the low rank adaptation technique fine tuning we cannot do on the 16 GB RAM, definitely, right? So what we will do, we will first quantize the model, and to quantize the model we don't have to load everything at once. In chunks we can load. So 16 GB RAM, definitely we cannot load everything, but in chunks we will load 1 GB 1 GB 28 times maybe, right? And first we will quantize, we will decrease the precision of the model, and we will get somewhere around 7 GB, right? We will get somewhere around 7 GB. So we will get the new model which is quantized 32 bit to 8 bit, 1 byte per parameter, 7 into 1, 7 GB. So this is a model that we will have which is quantized. Now we need to do the fine tuning. Full fine tuning will take same as the training, that we cannot do. 4 to 6x, we have 16 GB RAM limitations. So we will have to go with what? Low rank adaptation technique once again, because we quantized already. So Q low rank adaptation is quantization first and then apply the same technique. So this is going to take only 1x. So this will take only 1.1x extra, and that is 1 GB extra, 7 GB and 8 GB. So first you quantized and then you apply the same technique, you add some extra numbers, you freeze the model in low rank adaptation technique and you add some extra numbers, and that you train. And for that it will take 1.1x extra, 0.1x extra memory, and that definitely can be done on the same machine that you have 16 GB RAM. So this is how we decide everything. So obviously that will be less accurate as it is quantized, but we need to find the balance based on the machines that you have, based on the accuracy that we want for the user, based on what we have to serve to the user based on the use cases, right? So we need to understand that whether I should go for the full fine tuning, whether I should go for the parameter efficient. In the parameter efficient also we can go with two approaches. Directly with this will take much more memory because your model size is bigger already. So we need to decrease the model size, and then for that we will do the quantization and then apply the same technique, low rank adaptation. So This is all about the quantization. So this is all something I wanted to communicate in this class. So we discuss first LLM. So I'll just give you the recap, right? So first we discuss the LLM, and I'll take the questions as well. There are a lot of questions which should be answered. I'll answer some of them. I have already answered going forward in the classes, right? So we started with the LLM. What exactly is that? And then we saw the limitations of the LLM, that it is good at offline thing, right? If you ask something, it can give you. It is good at understanding the sentences. All these things it can do. Very good at all these things, but it cannot give you the updated information. So we understood that LLM is large language model because of two things: a large data set on which it has been trained, and at the same time it generates the parameters dot bin, in which we have a large magnitude of numbers present in that, and that magnitude will be in the range of 100 millions, 100 billions, right? And because of that, the size is bigger. So that we saw in the LLM. And after that, we discussed uh, that LLM works completely offline. So it cannot retrieve the data from the internet. It cannot make a network call. So because of that, we introduced RAG. So RAG is just a technique that we will feed some, just a terminology used to feed some extra information from the internet into the LLM, or from the document, from the database. Source could be anything. So it is just that is a term to use, right? A RAG. So then we saw that if we keep implementing RAG and all those things one by one, our backend is becoming the super brain, and that is something we need to avoid, right? So let the LLM be a super brain. So for that, we introduce the MCP for that, right? So MCP is a standard protocol for the AI application to interact with the AI systems, actually, right? So that is something we discussed, that MCP exposes the metadata, right? It exposes the metadata, and for that matter, our backend has to retrieve all the metadata and send it to the LLM. So LLM can recommend you which tools to use. So LLM has become brain now, right? So that is all about the MCP that we discussed. So we will transfer all those things to the LLM, that super brain logic. And then we discuss a little bit about the vector DB. It was not to be discussed today, but important. I thought let's discuss that, right? So because of that, we discussed the vector DB, and we saw the capability of the vector DB, so that we can have the faster response. We should not be sending the whole content of the PDF into the LLM because of two limitations: slow responses and the context window size limitation. So that is something I wanted to communicate here. Okay. So that was about the vector DB in association with the MCP that we discussed. So then I discuss all the flow that it has. Then we ask the LLM that you explain me this in a simpler way. So for that, we had to fine tune the model for the specific use case, for the coding, for the explanation specific to outcome school, right? We can fine tune the model, right? So then we saw this. After that, we discuss what exactly is agent. Any piece of code that does all these three things to complete a complex task will call is at an agent, right? So don't go with the buzzword that is having on the internet. Just understand in a very very simple way. So you write 5 lines of code, you can just name it as an agent.py, agent.cpp. That is your agent, right? So it is acting on the behalf of you. It is taking some actions, decisions, using some tools. Tools could be a simple network call, right? So that is an agent. And to build the agent with the less boilerplate code, you can go with a library like LangChain, LangGraph. So many libraries are there for that. Okay. So don't rely much on the library. First, it is very important to understand the concept, right? What exactly is AI agent? Now, whatever you want to use, X library, Y library, Z library, ABC library, you can use whatever library you want, right? But understanding what exactly is agent is more important than using the library, right? In a simple term, if you can't explain, you have not understood, right? As simple as that. I understand. Okay. So now we saw that after the fine tuning, we discuss agent, and then we discuss the quantization. So we need to reduce the model size for our machine, because our machine capabilities might be limited in terms of memory, right? We need more RAMs. We cannot increase in some situation, right? So for that, we will do this. So fine tuning, quantization will be like in 5 to 10 minutes you can do, right? It all depends on what is the size of the model, how you are done, doing that in the parallel or chunk series, right? Just read all the numbers, decrease the precision, and output dump into the new file, right? So that is what the quantization is. Fine tuning will depend on the timing of the fine tuning will depend on how much new data that you have for the specific task. So for example, if you have only 5 MB of data from the outcome school, so it might take in the range of 5 to 10 minutes on your machine as well, right? But if you have the whole data of the internet for creating the foundation model, so that can definitely take 100 days in fact, right? So if you see some data, right, so if you train on your machine, try to create the large language model on your machine, so it can take 100 years, 200,000 years in fact, right? So that is why we use the GPU for the parallel computation, and that can definitely cost us at least bare minimum $10 million, right? So but earlier those was created, right? Those model was created. OpenAI invested 100 million for the first time, right? And then if you have seen on the internet, the deep seek that taken over the internet when Chinese model got released. So they explained that we have done the same thing what OpenAI has done with the $100 million. We have done the same thing in $10 million with a very small team. So these are the research work that is happening. So model will keep on evolving, it will keep on getting better, and accordingly the product will keep on getting better and better and better, right? So definitely we cannot have that at your machine in as of now, right? But yes, quantization and fine tuning, part of the fine tuning or full fine tuning if you have the less data, can be done on your machine as well, right? So in my actual AI/ML classes, we cover exactly the code to code this, right? So in fact, we code this complete AI tutor, uh, each and every flow that you are seeing here with the complete code in Python, and then we will also create the LLM from the scratch. So I completely believe in the fact that if you have to learn something effectively, doesn't matter that if will be directly asked in the interview or not, right? If you're going for the AI engineering interview, so they might not ask you very specific thing about the internals of the LLM, but one thing I'm sure that if you understand how to create that LLM in and out of that in a very simple way, like a very small model, right, just for the learning purpose, so you will have the full confidence when someone asks you anything around the LLM, right? And that is something I want from all of you, so that you should be learning all those things, right? So it's just not that just what is needed for the interview. So what is needed for the interview is good, right? But there is a difference. What is needed versus your full preparation, right? Both things are important, right? So what is needed will give you higher. Your full preparation will give you a strong hire, and that is something I want from all of my students. A strong hire in every interview, right? If you have the interview tomorrow, today you should be sitting and telling that yes, tomorrow is my interview and I can go and crack with the 100% confidence I'm going to crack this interview, right? And that is something can be done only and only with the knowledge of internals. It cannot be done just by having what is there in the syllabus. So to do that we need to put a lot of effort, right? So study only. I was seeing this Hardik Pandya, that moment when he bowled and the batsman hit the ball in the air, and he started moving, walking towards the player batsman as if he was very confident that now the catch will not be dropped, right? So from that, we software engineer has a lot to learn, right? Hardik Pandya is very good at doing the background preparation, very very good, right? And I salute for that, right? So he has done all the preparations that he is not bothering about the result. Ball is in the air, will be caught, will be dropped, doesn't matter, right? I am 100% prepared. I have done my best. If not this time, next ball I will get the outcome, right? So that is what level of preparation that we need to do. So we have a lot to learn from that event as well. So whatever you see, right, try to learn from that, what we have to learn from that event. So same thing I recommend to the software engineers. You should focus on the complete 100% preparation, right? So you should be prepared in such a way that yes, tomorrow's interview I will crack that. You should not wait for the result, because nowadays there are so many things happening in the world, right? Companies are hosting, taking the interview, not replying, and they will never give you the feedback. Always you will have what? Unfortunately, we will not proceed with the application, right? That is not the feedback, right? So it is very difficult because of the time constraint to give you the feedback. So from that perspective only, you should do the preparation of such a level that you are not relying on what? The outcome, the result. You should not be demotivated with the bad result. You should be motivated enough that yes, okay, result could be anything. Next interview I will go and I will crack. And that will happen only because of what? My next level of preparation. And that is something I want from all of you. So let's be motivated for that and try to learn effectively, and everything build end to end, not just for the interview, for your curiosity as well, and to do the next level of preparation. So that is something and I want from all of you. So most of the questions I have answered already in the classes. So someone has asked, starting a new batch for the AI engineering, right? So I am already doing a batch. If you want, you can check outcome school uh, website, where I teach both the thing, AI engineering and the ML. So as I feel that to become a better AI engineer, right, you need to also know how to build the LLM. So my 50%, 60% of the course will be covering the AI engineering and 50% of the machine learning. So both the things are important, even though if you get 20, 30% of the ML part, right? So that is also more than enough to have that level of confidence. So that is something definitely will be useful. So I feel that, right? And I have seen uh, many good, great outcome from doing all these things, right? So in the Android only, in the backend only, right? If you just learn from the surface level, that level of confidence you will not have. To have the confidence, you need to do like really great for that, right? Great level of preparation, learn the internals, go beyond the syllabus, right? So I I remember in my college as well, one of my friend who used to be the topper of the batch. So even though someone mentioned that, okay, so we haven't discussed all these things in the classes. So for this exam, only this will be the syllabus, right? But I have seen this and that has inspired me, right? So he used to cover everything apart from what teacher mentioned in the classes that we will cover only this for this exam. He used to cover everything, and that is why he was a topper, right? So from the same angle that we can do a great, right? Someone has asked that. Hmm, okay, so what is relevant? I will, so that I have covered. Fine tuning is always needed or not, right? So fine tuning is for a specific task. So if you are going to do the coding task, right, maybe the general model will not help you with that. And on the top of that, you should have the data. So if you are operating in, for example, legal field, so you need to have all the legal documents, legal data, PDF, right? So on that you can retrain the model. So fine tuning can only be done if you have the required data. So and definitely for your private company you can do privately, right? So fine tuning is something you can do by taking the open source model, fine tune that and use at your company level. Someone has asked, I have the image data set, how can I make it, right? See, whatever I have discussed today is LLM, large language model, very good at what? Very good at particularly the text sentences. So to do something with the images, you need to go with the model which is good for particularly images, right? So there are architecture like convolutional neural network that is very good for the image, that also I built from the scratch in the classes. And there are few things like multi-model. So today we discuss a large language model that is only capable of operating on the text. But when you talk about the multi-model, it can take audio as an input, it can take images as an input, and it can take text as input. So it has all the capability, right? Ultimately, image is what? Ultimately a text, ultimately a numbers, right? So right now people have started thinking images as a sequence of words, sequence of characters, right? So if you see the images, right, first color, second color, third color, fourth color, like that, you have the matrix. So just think they are the sequence of characters, sequence of numbers. So right now people are experimenting that this LLM is being used for the image image understanding capability as well, right? So LLM has transformed a lot of things in this LLM world, AI world, right? So if you think the audio as a simple text sequence, a number sequence, same thing, right? So that is how it is happening as of now. What is the next question? So someone has asked that to work in LLM, do we need to completely change the domain of AI engineering, or we can stay? See, whatever your current domain is, right? So I think going forward within 1 to 2 years, it is going to add an extra layer on the top of what you are already doing. So that is called AI integration. So you should be very good at thinking about, see, I believe in product engineer, not in just an engineer. Engineers means you can code and you can do everything, right? But you need to start thinking from the product perspective. I completely believe that the compensation that you get from the company is directly proportional to how much value you can provide the company, right? In fact, your salary can become 10x in a matter of time, and that is definitely possible, right? So you just need to provide more and more value to the company. So just by writing the code versus writing the code and recommending and participating what can be done in the product, and that you can do only if you understand what we have discussed today, right? Otherwise we will say, okay, we have to do this, we will use LLM. So LLM might be the overkill for a smaller use cases, right? So we need to understand what is the capability, where I should use and where I should not use. So it is more important to understand where I should not be using. Very, very, very important for all of us to understand that. So that is something I will recommend everyone, right? So going forward, AI integration, if you see, right, last 100 company got funded from US Y Combinator. If you see the list of that, you will see that 99% of the company are the AI wrapper. AI wrapper means internally they are using AI. On the top of that, they are building the product. So, for example, there is a company called XYZ that does the same thing what we discussed, AI tutor. So you can go upload the PDF, ask the question. You can go. So basically, you can ask so many things, like you can ask the website to generate the quiz around this, right? Quizzes on the topic that you have mentioned. Then it can track your progress as well. So it's a AI wrapper, right, over the LLM, over the other models. So these types of companies are getting open right now and they are getting funded. So most of the companies are AI wrapper over the LLM and the other models. So out of 100 companies, 99 companies are same, building something in the AI, right? So if you see, read the job description. So there you will see mobile AI engineer, right? You, if you have the knowledge of mobile, completely good, completely fine. But if you can integrate AI in the best possible way, otherwise we will do blunder. Blunder like what? We will say that, okay, this is the model. I will put this model inside the Android device. You need to think from the quantization. You need to think from the fine tuning perspective, right? What is feasible for these use cases? Whether I should have the model on the client side or I should have the model on the server side. So this system design knowledge will help you, right? So uh, day before yesterday or 1 or 2 days back, I created a video. Uh, Writing the code is not the biggest asset at all, right? We need to start thinking from the system perspective, right? So see, I can just write all the code in half an hour. All these, in fact, I have done in the classes as well, right? So half an hour. That is not important. What is important is that where we will use which system, how they are going to be connected, how this backend is fetching all the metadata information. What is important? The description is important. The tool name is important. What is important? How LLM is deciding which tool to recommend, right? So these things are more important than any other things. So start thinking from the system perspective. Provide as much value as you can to the companies. I'm 100% sure that you will be rewarded with the highest compensation in your company, right? So go and start doing that. But that will come only from the knowledge. Otherwise, I have seen many developers talking about the LLM in a very, very vague way, right? So one example was that for doing the analytics on the client side, right? So one of the developers asked me that I'm going to use the LLM for the analytics on the client side. Is it really needed? The answer is obviously no. So we cannot just go and use anything on the client side, right? So we need to understand what LLM is good at. LLM is very good at what? Understanding the context, what user is saying. So the good idea will be what? Uh, Maybe if you understand that LLM cannot be used on the client side, we'll put on the server side. You ask the user that you speak to the application, right? So first we will do what? Translate the audio to the text. So user asks that, okay, I want to change the settings of this application for getting the notification, right? So like that user has mentioned, the user can speak to the phone to the application in so many ways. It can be framed in a very, very different ways by the different users in many different languages maybe, right? So we need to first convert by using some model by using the Android default capability, speech to text. Now from the text we need to get the intent, right? We will get the intent. Okay, this is something user has asked. To get the intent, better to send the text to the LLM. If we can do that at the company level, completely fine. Or we can use some regex, what user is asking, some smaller model on the client side, if possible, right? So we need to think from that perspective. What is feasible on the client side? What is feasible on the backend side? So if some product use case is very, very important, so start thinking from that perspective that okay, I can help the company with this level of capability, right? And this idea I get from, if you see, right now also many people book the flight ticket using the phone call. They do not want to use internet and go and book and flight, right? Calling the agent is fine, right? So they do not want to type something, do not want to do something. Instead of that, they want to talk. So why not I can talk to any application, right? And definitely it is doable in Android using that Google Assistant and so on, right? But we can have very specific use case for your application, right? For example, you are a developer working at Make My Trip. So you can build the complete app in such a way that I'm talking to the Make My Trip app, and it is taking all the actions on the behalf of me. It is just asking me for the confirmation, right? So like that, for the confirmation also, it can ask in the audio format. So like that, we can uh, build the features on the products, right? So this is how the things are evolving. So every company has started using the AI wrapper on the top of what they already have, and they are pushing more and more in terms of research. I have seen at this company only, right? People have asked that you start experimenting and giving the prototype of some product use cases where you can go with the AI. Sometimes it might be the overkill, but the thing is that the world is moving towards that, right? So we need to definitely start thinking from that perspective, that how I can help the company with the better product use cases, how I can help the company with the better AI integrations, right? So for that, we should understand the system at the first level, right? How is the communication happens between the MCP server and the vector DB? So MCP server, see, again, we have to think that MCP server is what? A server code written by a developer, right? Simple. A developer can write few lines of code to connect to the vector database, right? So like you do in the, if you're an Android developer, you query the SQLite, right, using the room database. So your file is present on the local devices. So here you will interact with the another system. Another system means API call. So your MCP server will make the API call to the vector DB. So like that, we need to think. Okay. I think from my side, I have completed everything and what I wanted to discuss. And at the same time, I have answered most of the query that we have, right? So one last query, that from where we can get the model size and which we can install on our machine. So for you, I will recommend explore the Olama website, which I already mentioned, right? Olama is a website. Just start exploring that. You will be able to run all the models on your machine for which for your machine is capable enough, right? So you can try all those models, right? I think Llama 3 you can run. I know you very well that you have MacBook for sure, right? So you can MacBook Pro, you already have, so you can do that. uh, Llama 3 you can try via Olama. So Llama 3 is a model by Facebook Meta, open source completely. And Olama is a tool that you can use to download the model and use completely in the offline format on your laptop, right? So and you can actually go and browse what Olama has downloaded. So you will see that there is a model Python file and there are few parameters.bin in chunks, right? So now it will make more sense if you read anything on the internet or if you do anything on your machine related to LLM, right? So let's think about more and more about the systems, right? So with this, I'll wrap up the class, and whenever I do any next session, right? So just keep watching my YouTube channel, so you will get the notification when I go live once again. So it was great communicating with all of you, right? I had to do few things with the proper guideline because I'm the only person working today for Sunday. So good day, everyone. Take care, and I will see you in the next session whenever I do. Thank you so much, everyone, for joining.